On a hot summer day, Max is much more likely to get sunburned due to the intense sunlight. Max is also more likely to eat an ice cream due to the intense heat. One may wonder, how are these situations connected? Do rising temperatures lead to an increase in the likelihood of both sunburns and ice cream consumption? This leads us to explore the three important concepts of correlation, causation, and linear regression. Correlation refers to the connection or relationship between two or more variables, showing a statistical relationship. There are three main types of correlations: positive correlation, negative correlation, and no correlation. Positive correlation is when one variable increases, the other variable also increases. Negative correlation is when one variable increases, the other variable decreases. No correlation is when there is no distinct relationship between the two variables. Correlation is commonly used when describing the relationship between two variables. However, it is not the most reliable, as such a correlation might be due to coincidence or other third-party variables. It does not imply that one variable or event causes the other variable or event.
Causation refers to a change in one variable or event, directly causing a change in another variable, establishing a clear cause and effect relationship. To claim causation, two key conditions must be met. First, there must be a significant correlation between the variables. Second, either a temporal order must exist, where one variable clearly precedes the other in time, or there must be a strong, theoretically justified reason to believe one variable influences the other. For example, if the age at which a child first speaks sentences correlates with later school success, and since speaking age happens before school success, it's reasonable to infer causation in that direction. However, correlation can be misleading due to confounding factors, such as a third variable affecting both variables simultaneously, like hot weather increasing both ice cream and sunglasses sales, which creates a correlation without causation. Linear regression models can help predict one variable from another by assuming a causal direction, but regression itself does not prove causality. The causal direction must be established beforehand based on the theory or experimental design. Therefore, while correlation shows association and regression models prediction assuming causality, true causation requires more rigorous evidence, including temporal precedence or theoretical justification and ruling out alternative explanations.
Correlation and causation both describe relationships between variables, but the distinction lies in the nature of the link between variables. Correlation is when two variables change together, but a change in one does not necessarily result in a change to the other. For example, in recent NBA seasons, teams such as the Golden State Warriors and the Boston Celtics have achieved extreme success, finishing as top seeds in their respective conferences multiple times. Both of these teams have consistently found themselves at the top of the charts for three-point attempts, and looking at this data from face value, one could conclude that shooting more three-pointers directly leads to team success. But it's also important to consider that the personnel these teams employ may be more suited to a system with high three-point volume, and that their success stems from the cohesion between the players and the system. The graph on the left shows the Boston Celtics three-pointers attempted per game against the team's winning percentage over the last 10 years. There is a positive correlation that can be observed, but the correlation only has a R-squared value of 0.35. This correlation does not indicate causation, as the win percentages could be due to multiple other variables that lead to the team's success. The graph on the right shows every NBA team's three-pointers attempted per game against the team's win percentage over the last 10 years. We can observe that, unlike the previous graph, there is no correlation and causation between the variable of three-pointers attempted and the percentage of NBA teams winning as a whole.
With the understanding of correlation, causation, and linear regression, we can now go back to the original situation. The intense heat on the hot summer day is the cause of individuals being more likely to get sunburned, and is also the cause of individuals eating more ice cream. As both getting sunburns and eating ice cream are variables that increase along with sunny weather, when there is an increase in ice cream consumption, there would also likely be an increase in individuals getting sunburned. Hence, there is a positive correlation between ice cream consumption and getting sunburned, but no causation, as there is no cause and effect relationship between these two variables. Max's situation is just one of many examples in which correlation, causation, and linear regression are used in the real world, which can help us predict many more real-world scenarios.